This is lesson 1-5, rules with exponents. So first of all, some things to recall of things that we've talked about already this year. The base is the number that's being multiplied, and the exponent is the number of times to multiply the base by itself. A couple of examples here for you. If we have 4 squared, we're going to take 4 and multiply it by itself twice, 4 times 4. Same thing if we had a variable. Please keep in mind that nothing changes when you go from numbers to variables. The process is the same. Special note for you as well, in case we haven't talked about it before. If we don't have an exponent, it means there is an exponent of 1. It is always assumed if there is no exponent written. Let's take a look at our first rule, multiplying with exponents. When we're multiplying, terms that have the same base with any exponents whatsoever, we'll just keep the base and we'll add the exponents. For example, 3 to the third power times 3 to the fifth power, if I write it out in long form, it's 8 3's being multiplied together. That's why we have 3 to the 8th. We can simply shortcut this by just adding the exponents. It is not necessary for you in your work to write out the elongated form. Rule number 2 is when we're dividing with exponents. When we're dividing terms that have the same base with exponents, we'll keep the base and subtract the exponents. Simply the opposite of what we did with Rule 1. Here's an example. 3 to the 6th divided by 3 to the third, again written out in elongated form, shows that 3 to the third is our final answer. Simply when we are going to cancel the first 3 3's. It's the same on the bottom with the x's. The first 3 would also cancel. And we're left with 3 being multiplied together. Again, the elongated form is not necessary when doing your work. Rule number 3 is the easiest of all the rules. Anytime you have an exponent of 0, it is equal to 1. Here's the proof behind that. We know that anything divided by itself is equal to 1. So, for example, 3 to the third divided by 3 to the third is equal to 1. That's a basic rule of division. Now, if we use our rules of exponents, rule number 2, 3 to the third divided by 3 to the third, subtracting the exponents, 3 minus 3, should give me 0. Therefore, since both terms are equal to 3 to the third over 3 to the third, then we could say that that to the 0 power is always equal to 1. Rule number 4 is the most complicated of all the rules. It's the negative exponent rule. When you see negative exponents, take the reciprocal and eliminate the negative. Here's an example. 3 to the negative third power gets moved to the bottom of a fraction, and since there's nothing left on top, we have to put a 1. In the second example, we already have a fraction, and we move the negative 2 down to the bottom, and the negative 5 up to the top. A third example for you would be if we had something like this. X to the third over x to the negative 2. The only thing that we're going to move is the negative exponent. So this moves up top. So we're left with x to the third times x squared, which of course by rule 1 is equal to x to the fifth. The key portion of this is knowing that the only things we are moving are those that have negative exponents. And of course, a special note, anytime you have negative exponents, you are not allowed to leave that answer alone. You must leave all answers with positive exponents. Rule number 5 is the consecutive exponent rule, sometimes known as power to a power rule. When a term is raised, when a term with an exponent is raised to another power, we simply want to multiply the exponents together. Here's a couple of examples. As you can see, we have consecutive exponents written. In the first example, we have a 3 as an exponent, followed by a 4. In the second one, we have an exponent of 4, followed by another exponent of 2. When we have consecutive exponents, we multiply them together and keep the base. Here's some examples for you to try on your own. Pause the video at this point to give yourself a chance to try them. Here are your answers. For the first one, 3 to the 4th times 3 squared, we're going to use rule number 1 with multiplying, and we get 3 to the 6th. Now, anytime you have numerical answer like 3 to the 6th, we should be evaluating that, and in this case, 3 to the 6th evaluates to 729. For the second one, x to the 4th divided by x squared, we'll use rule number 2 and subtract the exponents, and we get 4 minus 2, which is 2, so the answer is x squared. For the third one, the first thing we need to do is add the exponents. So negative 2 plus negative 1 is a negative 3. So that gave us 4 to the negative third power. We needed to move it down to a denominator. So now we have 1 over 4 to the third power. When evaluating that, that becomes 1 over 64. For the last one, the entire thing is equal to 1. To show you how that works, the first thing we have here is consecutive exponent rule, which gives us x to the negative 8. Then we have the multiplication rule, where we're going to add all the exponents. And negative 8 plus 3 plus 4 plus 1 gives me x to the 0 power. And as we know from rule 3, anything to the 0 power is equal to 1. If you're having any issue with any portion of these notes, please make sure you are emailing me or consulting me in class.